First, we're going to talk about the x-intercept. Let's say we have a line drawn in the xy plane. Wherever this line crosses the x-axis is called the x-intercept. So in our particular graph, we can see right here on this red dot is where our line crosses the x-axis. Notice here, if we were to describe this as an ordered pair, we would have some kind of movement to the left, but no movement up or down. So we might say that the y-coordinate of our x-intercept is y is equal to 0. So this gives us a strategy for when we're trying to calculate the x-intercept of a particular line. If we do have the formula for our line, what we do is we set the y-coordinate, or the y value, equal to 0, and try to figure out what the x-coordinate is of our ordered pair. So setting y equal to 0 in our equation gives us 0 equals 3x minus 6. We can move the 6 over by adding 6 to both sides of our equation, and we have 6 equals to 3x, and in our final step we're going to isolate x by dividing by 3. So here we're going to get x is equal to 2. Now be careful, the x-intercept is not x equals to 2. That's the x-coordinate. The x-intercept is an ordered pair. So in our question, we might finish by stating that the x-intercept is the point 2, 0. We could also define something called the y-intercept. If we have the graph of our line, we say the y-intercept is wherever our line crosses the y-axis. In our particular example here, down in the bottom right, our line crosses the y-axis somewhere around here, so that's the point where we would call the y-intercept. Notice that the y-coordinate of this point would be non-zero. There is some movement downwards. However, there is no movement of this ordered pair to the right or to the left. So the x-coordinate of our y-intercept is equal to 0. Let's finish off with one more example. We're going to go ahead and calculate the y-intercept for the line 0.2x minus 0.3y equals to 0.9. Remember that our strategy is, if we're trying to find the y-intercept, we are going to make the substitution of x is equal to 0. Once we do that, we're going to be left with negative 0.3y equals to 0.9. And we could finish off by dividing both sides by negative 0.3. This is going to leave us with y equals to negative 0.9 over 0.3. Remember, when you're working with decimals like this inside of a fraction, we could multiply both the numerator and the denominator by powers of 10, or in other words, we could shift the decimal in both the numerator and denominator at the same time. So our y is really equal to negative 9 over 3, which is negative 3. Of course, if you used long division and did 0.9 divided by 0.3, that would be okay as well. You should end up with the same final answer of negative 3. All in all, we can say here that our y-intercept is 0, negative 3. Now the slope of a line tells us how quickly the line is either increasing or decreasing. If our line is of the form y equals mx plus b, then this value in front of the x, which is m, is going to represent the slope of our line. Now, when we say slope, we generally want to talk about the ratio of how fast the line is moving in the upwards or downwards direction, which is sometimes called the rise, to how much the line is moving in the left or right direction, which is sometimes called the run. So most often you may have heard the slope described as rise over run. So if we do have to calculate the slope of a particular line, we can use our rise over run formula that we've made up on the last slide. To be able to use this formula, we need 2 points on the line. I'm going to call those 2 points x1, y1, and x2, y2. So these are 2 ordered pairs. And our slope is equal to the difference of the y-coordinates, we usually call this y2 minus y1, divided by the difference of the x-coordinates, and we call this x2 minus x1. If we perform a slope calculation and we get a slope that is a positive number, now this could be a positive whole number or it could be a positive fraction or decimal number, then we know that our line is going to slant upwards and to the right. So one example of a line with a positive slope is drawn here on the right. On the other hand, if we go to use our slope formula and we get a negative slope, this means that our line is going to slant downwards and to the right. So one example of such a line is given here on the bottom right. Let's go ahead and calculate the slope if we know that 2 points on our line are negative 1, 1 and 2, 3. So remember our slope is given as rise over run. Rise is the difference between our 2 y-coordinates, and run is the difference between our 2 x-coordinates. So up at the top we could go ahead and label our points. So maybe we'll call negative 1 x1 and 1 y1. 2 we could call x2 and 3 we could call y2. And now we can go ahead and just make direct substitution. So we have 3 minus 1 and 2 minus negative 1. Simplifying our numerator, we get 2, and simplifying our denominator, we get 2 plus 1, which is 3. So our slope must be 2 over 3. Since our slope is a positive value, we would expect our line to slant upwards and to the right. Now there are a couple of extra cases that we do have to consider when we're calculating our slopes. The first one is the case that we have a horizontal line. So remember that a horizontal line looks something like this. And in this case, there is no movement up or down between our ordered pairs. That means if I were to plot an ordered pair over here, and a second one over here, and I look at the difference between the 2 y-coordinates, both of the y-coordinates are equal to 3. This means when we go to calculate our rise, we're going to get 3 minus 3 for 0. So no matter what values we have for x, we always get a 0 in the numerator. This means that a horizontal line is going to have a slope equal to 0. The second odd case that might occur is we might have a vertical line. So let's plot a couple points on this vertical line. Let's say we have one here and one down here. I want you to notice in this case that the difference between the 2 x-coordinates of these ordered pairs is going to be 0. There is no run to the left or to the right. So our slope, no matter what our y-coordinates might be, is going to be rise over 0. Because this fraction is undefined, we say that the slope of a vertical line is also undefined. We say that 2 lines are parallel if they have the same value for their slope. I've drawn 2 examples down here at the right. Our blue lines are going to have some kind of positive slope, and their slopes are going to be equal. Also, these red lines are parallel. Since they're both horizontal lines, they both have slope equal to 0. We say that 2 lines are perpendicular if, when we multiply their 2 slopes together, we get a product of negative 1. Let's take these 2 lines as an example, 5x plus 2, and negative 1 over 5x minus 7. Since both of these lines are in slope-intercept form, we know that the value in front of the x is going to be the slope of our given lines. And if we multiply these 2 values together, 5 times negative 1 over 5, we get a product of negative 1. This means that our two original lines are what we call perpendicular. Now, perpendicular means that our lines intersect at a 90-degree angle. I want to make it very clear here that the two lines that I've drawn in this chart are not the two lines that I have here. The two lines over here are just meant to illustrate what it means to be perpendicular. Just to give you one more example of perpendicular lines, let's go ahead and show that these two lines are perpendicular. Now, we may have to do a little bit of rearranging in the first one to figure out what the value is in front of our x, because we have x over 2. Well, this is the same thing as 1/2 times x. So this means that the value that we're really interested in is a slope of 1/2, and for our second line we have a slope of -2. So let's go ahead and multiply those together, 1/2 times -2, and in fact we do get -1. Since we have a product of -1, this means that our lines are perpendicular. In our last question, we're going to see if the line passing through 2 points, 4, -2, and 3, 3, is parallel to the given line of y equals 5x plus 2. Well, first of all, let's understand that we have two lines here. Line 1 passes through the points 4, -2, and 3, 3. In line 2, we already know the equation for line 2. It's 5x plus 2. And in fact, if we need to figure out if these two lines are parallel, we already have all the information we need from line 2, and that is the value of the slope. So what we're missing from line 1 is the value of its slope. So we know that the slope can be found in line 1 by doing rise over run. In other words, we look for the difference of our y-coordinates and the difference of our x-coordinates. So let's go ahead and label our coordinates. So let's call 4 our first x-coordinate and -2 our first y-coordinate. 3, we'll call that our second x-coordinate, and the other 3 we'll call our second y-coordinate. So now we can make substitutions. We'll have 3 minus -2 over 3 minus 4. And what we get is 5 over -1, or the value of -5. So we can see that our slopes now are not the same. They differ by a factor of -1. This means that our lines are not parallel. Alright, my little epsilons, stay positive.